than the solution in problem 1. Okay, moving on. What is the pH of a 1 times 10 to the minus 3 molar solution of KOH? Is this acidic, basic, or neutral? Well, here I have added, I probably wrote this problem, another layer to the problem. Okay, so now we need to look at our substance KOH. First off, ask yourself, is this an acid or a base? Well, remember, anything with OH minus in it is a base, and not only is it a base, it is a strong base. Okay, so here the problem's not going to be as straightforward. We can't get pH from the concentration of OH minus, directly at least. There's a way around it. But what can we do? Okay, so if we have a strong base, KOH, how is that going to react? Actually, I want to write it, I believe, up here. KOH plus water. These are in aqueous solutions. This is a strong base, so a single arrow here. And the OH minus, remember the K here, potassium? He's a spectator ion. So this is not going to participate in the problem. We really have OH minus as our base. It is going to grab a proton off of water, so water is acting like the acid here. And when that happens, OH minus plus a hydrogen makes H2O, and what's left over from water, who is our acid in this case? Once it gives away a hydrogen, we have OH minus left over. Okay? So, every bit of this KOH is going to react with water. So that means if we start out with 1 times 10 to the minus 3 molar KOH, all of it's going to react and we'll have 0 left over. And we're going to get all products, okay? Now, water is the solvent here as well. So it's kind of impossible for us to say what the concentration of water will be. But we do know we should get a concentration of this product, OH minus, which would be the same of the amount of base we initially started with, 1 times 10 to the minus 3 molar. Okay, remember, we're just saying all of this KOH, every bit of it, 1 times 10 to the minus 3 molar, that's how much we have. All of it's going to react, so we'll have 0 of this reactant left over, and we'll have all products. That's why I said the concentration, of OH minus over here is going to be equal to our starting material only because it is a strong base. Okay, now that we've got that all sorted out, if we know the concentration, I'll write this down here, of OH minus is 1 times 10 to the minus 3 molar. Then what that means is, how can we find, again, let's write out the equation for pH. pH equals negative log of H plus. To solve for pH, which is what the question is asking for, we need the concentration of H plus. We don't have the concentration of H plus. How can we get it? If you watch the previous videos, we have a way, and it's through KW. KW equals the concentration of H plus times the concentration of OH minus. We know the value of KW always. It's 1 times 10 to the minus 14, and that's a constant. It never changes. We know the concentration of OH minus here is 1 times 10 to the minus 3. So we'll plug those things in, and then we can solve for the concentration of H plus. So I'm going to bring it over here. We have 1 times 10 to the minus 14. What we need to do is divide both sides of the equation by the concentration of OH. So we know this equals the concentration of H plus. I'm going to plug in my concentration of OH minus, 1 times 10 to the minus 3 molar. Divide both sides by 1 times 10 to the minus 3. And what you get, this cancels out over here. So 1 times 10 to the minus 14 divided by, put this in parentheses, 1 times 10 to the minus 3. When you put that in your calculator, put it in parentheses, you will get 1 times 10 to the minus 11 equals the concentration of H plus. All right, and that is molar. Now that we know the concentration of H plus, we can plug it into our equation for pH. So pH equals, or if you notice, our base number here is 1. If our base number is 1, pH is just equal to our exponent. So pH should be equal to 11. But let's double check. Do the negative log of 1 times 10 to the minus 11. Do you get 11? I sure hope so. Okay? So, if you are given a concentration of OH minus, and here we were because we started out with a strong base, to then solve for pH, we first have to get the concentration of H plus. We did that using KW. Okay? Once we had the concentration of H plus, we plugged it in to our pH equation, and we got pH. If pH is 11, we know that any pH greater than 7 is basic. So the second part of this question, is it acidic, basic, or neutral? It is basic. Okay. All right, that's a little bit on how to solve for pH. Now we're going to talk about the pH. Well, we've talked about pH. Now we're going to talk about how to undo pH. Okay, so here's a great question. What if we are given the pH and we want to know the concentration of H plus? What if we're given pH and we want to know the concentration of H plus? So here what we've been doing is we've been given the concentration of H plus and solving for pH. Now we're going to work backwards. And I put this link on the chapter 10 slides. So this is on Blackboard. This link is available. I think this is a great video that walks you through what I'm about to do. But just so you know, you can also go check out this video on YouTube if you don't like the way I explain it, or if you're still confused and just want someone else to walk through it with you as well. So this is going to show you how to solve for the concentration of H plus if you are given a pH. Okay, so here's our equation. We know this. How do we undo that to solve for the concentration of H plus? Step number 1, move the minus sign over. When we do that, we get negative pH equals the log of H plus. Okay, this is a perfectly valid thing to do in math world. So we move this minus sign over. Now take the anti-log. What does that mean? Okay, well, log, it's a function in our calculator that is what we call a base 10. Okay, so that means we're going to raise how do I say this? We're gonna raise these things to the exponent place by saying 10 to the power of whatever. Okay, so we're gonna raise the log of the concentration of H plus to the exponent. We're gonna say 10, and now our log of H plus is the exponent. And then we're gonna do the same thing on both sides, because you have to in math world. Okay, so 10 to the power of negative pH. Now negative pH is our exponent. Well, when that happens, this 10 and this log cancel out. Okay, because we just did the anti-log on a log, and when you do anti-log on a log, it cancels the log. Okay, so what we're left with is 10 to the negative pH equals the concentration of H plus. Okay, so this answers our question. If we're given pH, let's say we have, well, we're actually going to look at that on the next slide. But if you're given a pH, you do 10 to the power of negative pH, put that value as your negative exponent. I made it look like a 1. And that is going to be equal to your concentration of H plus. All right, let's practice this. So I'm going to write this equation down here. 10 to the negative pH equals the concentration of H plus. All right, if a solution pH is if pH of a solution is 8, what is the concentration of H plus? So we're just going to follow our equation. 10 to the negative 8 equals concentration of H plus. So if you put that in your calculator, it'll probably tell you it is 1 times 10 to the minus 8 molar. Okay? If pH is 4.5, what is the concentration of H plus? Well, here's our pH. We do 10 to the negative 4.5. When you do that, you should get that concentration of H plus. You can't leave it like this, all right? You need to actually put this in your calculator. 10 raised to the power of negative 4.5. And then it should give you a value. I got 3.16 times 10 to the negative 5, okay? We don't like to communicate with exponents that are decimals. That is why you need to put this in your calculator and get a value with a whole number exponent. Okay, you can't leave your exponent as a decimal. In this first one, we had an exponent that was a whole number, 8. There was no decimal. So we could leave it like that. But here we have 4.5. So put that in your calculator and then you'll see it gives you a new number with an exponent that is just a whole integer, negative 5 here. And that would be molar. Okay, if pH is 12.3, then we're going to do 10 to the negative 12.3 equals concentration of H plus. We have a decimal in our exponent. That's not good, so put it in your calculator and you should get that H plus concentration is 5.01 times 10 to the minus 13 molar. Oh, and I didn't even finish reading the problem. It says, what is the concentration of OH minus? So we're not done. We solved for the concentration of H plus, but we want to know concentration of OH minus. Now what do? How do we get concentration of the hydroxide ion? We have to use Kw. Kw equals H plus times concentration of OH minus. So we'll divide both sides by H plus concentration of H plus. It'll cancel out on this side. So what we get is, come down here, Kw, I'm going to plug the numbers in now. Kw is 1 times, I don't know why I put a decimal, 1 times 10 to the minus 14, that's Kw, divided by, we're doing this step, divided by the concentration of H plus, which is right here, 5.01 times 10 to the minus 13. Put this in parentheses. That is going to be equal to the concentration of OH minus. And when you do that, you should get that OH minus is 2.0 times 10 to the minus 2 molar. Okay.